Alright, today I'm going to show you how to code a simple game of Connect 4 in VBA. Why Connect 4? It's fairly easy to code. It doesn't require anything crazy algorithmically speaking. You don't need complex functions or anything like that. It's a good beginner's game. It forces you to learn some things about UI and just get used to basic concepts about loops and such. So it's a good way to practice. The first thing we're going to do is select every single column on the sheet and resize them so that they're square by setting them to 20 pixels or so. That way it looks nicer and we have a neat play area. Next, we're going to select an area in the sheet, let's say 10 rows and however many columns it is. And we can say this one is going to be the place in which we're going to play the game. So I'm going to enclose it. Maybe that's too many columns. I don't know. Anyway, the way we're going to let the players play and choose where they're going to place the pawns is with buttons. So what we're going to do is go in the Developer tab and use Insert Form Controls, the first one, button. We're going to add a button to every single column. What you can do is copy it, then paste it into the next cell. We can't use tab to move from column to column, but you can just click with your mouse, it's not the end of the world. There we go, now we have a ton of buttons, and we're going to assign a different macro to each of these buttons. Now, as always, in programming, if you find that you're repeating yourself, it's because you're making a mistake. So if we say wrote something like this, button 1, and then with that macro we add something like button 1 place a pip in column 2, then sub button 2 place a pip in column 3, and so on. Then that code, however many lines long it would be, we would repeat like 20 times. That would be awful. We're not going to do that. We're going to be smart about it. We're going to have each of these buttons consist of one line of code, which is going to be to call another macro, which we're going to call placePip. That macro is going to take an argument, and that argument is going to be the column number in which to place the pip. That way you're not repeating yourself. This is good not only because we're deeply lazy people, because we're doing programming, but also because the more you repeat yourself, the more likely it is that you're going to have a typo, that you're going to make a mistake, or that when you change things around, you forget to change it in one place and not the others, which makes debugging very challenging. So all of the buttons are going to call the same macro placePip with a different argument so that the code is all in one place. Now, how are we going to find where to place the pip? What we can do is start on row 11 and go up row by row, and the first time we find a row that is empty, we're good. For I equals 11 to 2 step minus 1. If the cell in row I and in column call the argument that we received from the button, if that cell is empty, then we can place a pip in it. Cells I call takes the value. For now it's going to be 1, I'll explain how we're going to do that later. If cells I call is empty, we place a pip in it. Otherwise, we keep going with the loop. And if we leave the loop, it means that we did not find a single empty cell in all of that. So we need to display an error message of some sort. Message box cannot play in this column. So we're not going to display a 1 every time. We're going to display 1 or 2 because it's going to be the turn of player 1 or player 2. So what we can do is this. Turn player here, and in R we're going to display either 1 or 2, which means that when we play successfully, we're going to want to switch the value of that cell around. That cell R2 is going to keep track of who is the turn player. If it's a static value, so we can just write this way, R2. If R2 is equal to 1, then R2 takes the value 2, otherwise R2 takes the value 1. That way, it's going to constantly flip between 1 and 2 every time we play. Now, we're not going to put always 1 in the cell because we want it to symbolize the player who just played. And if we do that, then the entire grid is going to be flooded with 1s and 2s, which is going to be unreadable for the players. What we could do is use complicated symbols or colors and so on and so forth, but that's not super interesting to do in VBA, so if we can offload some of that uninteresting work to Excel, we're going to do that. The way we're going to do that is by using conditional formatting. We're going to set 2 rules. In this area, we're going to format cells that are equal to 1 with a custom format. We're going to make the text pure red and the fill pure red as well. That way the cell is just going to turn red. And similarly, we're going to highlight cells that are equal to 2. We're going to make them use blue fill, this one, the one, and blue text. So here, every time I write a 1 and a 2, it doesn't look like numbers at all. It looks like colors, very readable for the player, very readable for the computer too, because the computer is just going to look at 1s and 2s, which is going to make checking for victory much easier. Cannot play in this column, blah, 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 blah. Let's see, what do we now? Yes, exit sub. So, if we find a cell that is empty, we display the player's number of that cell, and we switch the turn player, and we leave the macro immediately. If we leave the loop naturally, without hitting that exit sub, it means that we never found an empty cell. And so we display the error message box cannot play in this column. Right? Right. We're going to have problems if every single cell of every single column is filled, because no one can play anymore. So we need to display a message for this is a draw or whatever. But we can do it later. It's not super important to the main game loop, which we should finish first. Speaking of the main game loop, we're basically done with it. I am repeating myself here. I want to know whether I can find column the button. What we know is that we can access the caller of an application, what called it. If you call it through the macros menu, it's going to cause an error message. Application.caller. Application.color is going to return the button object that called this macro, which is going to be useful if we assign the same macro to several different buttons. So I don't know whether this can work. So what I'm going to do is assign the macro button1 to this first button. Try running it, object required, that doesn't work. What about this? Does it make sense to you? No. Sad. Then, since I want to look at the various properties of the color object, oh, it returns the name. It returns the name of the color, right? I forgot that's a thing. Then I can probably just active sheet.shapes. Shapes is the collection of all geometrical shapes, charts, and such in the current sheet. So that's going to give me the sheet with the name button1, which is going to be the button object. Then we can look at the properties of that. Just made alternative text, application of the shape type, background, black, white, bottom right cell, pull out. Bottom right cell seems like it's going to do what I want. What I really want is a top left cell. There we go. Great. So I can just do active sheet shapes application.color top left cell dot column. Does that work? Yeah, it does. Fantastic. Great. So that we don't need any of that, and we can just use the same macro for everything, which is even better. Call equals active sheet.shapes application.color top left cell column. We might as well declare column and get rid of the rest. So the way with the several buttons that call the same macro passing it a different argument, much more logical, also much longer to type, because here we have a ton of buttons. So here we have a single macro that does everything, which is very cool. It's not really a good habit to have, but we're using cute tricks, so something. So I think if I just assign a macro to all of these, it should be good to go. We can actually assign macros programmatically, so I could just write a macro that goes for each shape in ActiveSheet.shapes shape.assign macro or whatever the method name is to do it automatically instead of clicking everything. But whatever. Anyway, right now we're done with the main game. As you can see, it was extremely short. We did less than 10 lines of code, which I think is very reasonable. And the last thing we need to do is to handle endgame. So draw condition, victory condition. Draw condition we're going to handle with a simple count blank function. Using Excel functions in VBA is super handy, because that way you don't have to recode stuff. In particular, countif is awesome. Here we're just going to use count blank. So, if worksheet function count blank, the range is static, so we can just write a b2 p11 equals 0, then MSG box, the play area is filled. It's a draw. Exit sub. There we go, that's the draw condition taken care of. No player can draw. Every time you click on a button, it's going to display it's a draw. Next, we're just going to take care of counting alignments of pips, which is the hard part. It's the hardest part by far of coding a connect for. So we're going to delegate it to a separate macro to make it simpler. Check victory. The nice thing is we don't need to check for every single cell. We just need to check for the pip that was placed. So what we're going to do is, from a given pip, we're going to look at this alignment, this alignment, this alignment. No, that doesn't even make sense because what we actually need to do is to look at this alignment and check whether there is a sequence of 4 in there. Then look at this alignment, look whether we created a sequence of 4. Okay, I have one too many. No, I don't. Yeah. So check victory is going to take as argument pip as ranged, and we're going to look at stuff. For each cell in range pip dot offset -3 0 pip dot offset 3 0. So what does offset do? Offset is just going to add to the coordinates of a cell. So if my active cell is M6, we can do a little demonstration here. Offset showcase active cell dot offset -3 0 dot interior dot color equal VB red. This affects the cell 3 rows above and 0 columns of difference from the active cell. We subtract 3 rows from the active cell and we don't add or subtract any columns. I could do 1 1 and then it would give me the cell 1 row down and 1 column to the right. Okay, very good. It's not super complex as a function, as a property, but it's useful. It's shorter to write than the alternative. So for each cell in the range of pip.offset blah. So the problem with that is we're possibly going to look out of bounds, and we're also possibly going to look at cells that don't exist. What's the difference? Well, this cell is out of bounds, so we shouldn't count it, but that's fine. However, the cell A0 doesn't exist, and VBA is going to throw a fit. One way we can handle that is on error resume next. Another way we could handle that is by using actual coordinates and then using the main function to make sure the coordinates are within bounds. It's longer to write. We're just going to use on error resume next. The idea is the same. For each cell in range, pip.offset -3 3. If cell value equal pip.value then counter equals counter +1, else counter equals 0. Does that make sense? I feel like it makes sense. If counter equal 4, then message box player and pip and wins. Why player and pip? Because the pip contains either 1 or 2, so it's going to be the player number, so it can just display the player wins. Okay, does that make sense? We're looking up and down, I think it works. The cells outside, we're not doing any multiplication shit, so it's fine. Okay, for each cell in range, pip dot offset 0 minus 3, pip dot offset 0 3. As you can see, we're doing the exact same thing, except with horizontal instead of vertical. So we have a sequence of 7 cells, and we say if we find in here 4 pips in a row with the same value, we win. The problem is with diagonals, because Excel is not very good at handling diagonals, unfortunately. So the way we're going to do that, unfortunately, we are going to have to do 2 nested for loops. For I equal minus 3 to 3, for j equals minus 3 to 3, boring. Next time. Wait, no, I'm being stupid. I don't need 2 different counters because they have to have the same value in this diagonal. We're subtracting minus 3, then minus 2, minus 2, minus 1, minus 1, 0, 0. If pip dot offset I is equal to pip, that value even, then counter equals counter plus 1, else counter equals 0, blah, 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 blah. If counter equals 4, and okay. So that's the nice diagonal. Now we're going to have to do the reverse diagonal. Minus 3 to 3. Next time. If pip dot offset I minus I, does that make sense? Minus 3, 3, minus 2, 2, minus 1, 1, 1, minus 1. Yeah, that makes sense. Pip dot value. I think we're good. So this does one kind of alignment, this does another, this does another, this does another. Horizontals, verticals, diagonals, reverse diagonals. Question is, does this work? And the other question is, does this cause errors? Because we are potentially looking at a bounds. So is that going to work? I find it extremely amusing that the code to check victory is literally longer than the code for the rest of the game. We're also going to have another macro sub start game, which we're going to trigger with buttons. It's just going to clear the range P2, P11, and to set the turn player to 1. It's really not very complicated, and players could, I guess, do that manually, but if they were going to do stuff manually, they would be playing Connect 4 on paper. So we're going to edit that button to say start game. You may also have noticed that in macros, we have two macros visible, placepip and start game. We don't want anyone to run placepip from that menu, because if they do, application.color is going to throw a fit. It's going to cause bugs, it's going to look ugly. So we're going to hide it using private sub placepip. This is generally a good idea, hiding every single macro that you don't want people to run using private. It's less important when you have a clear button to start the stuff, because when there's a button, people are not going to go digging in the developer menu, hopefully. But still. Oop, 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 oop. Okay. Okay, did not say we win. Why? Because I'm not calling check victory. I forgot to call it. Okay. Cell check victory cells I call. There we go. Yeah, I forgot to advance. My bad. Yay! It detected the diagonal property. Okay, that seems to work. Oh, great job, me. So what did we learn today? Application.color is a very good way to handle multiple buttons that do the same thing modulo one value. Excel functions are very useful even in VBA, count blank, countf, min, max, sum. Mostly it's going to be the basic Excel functions that you're going to use because it's simpler to use the basic functions. They're relevant in more cases. And probably you're doing VBA because you need to handle complex stuff. So complex functions you're less likely to be using it. Simple functions are awesome. What else did we learn about using square brackets around the names of ranges? So it's much more readable. We could write this as cells to R, which is also kind of readable. The purpose of writing stuff this way is because you can use row coordinates instead of static coordinate here. So that's nice as well. You can also write range R2, but when you have a static cell reference, I like to just use square brackets. I think it's the most readable. We learned a bit about offset, and we figured out how to do a connect for. So I hope that was interesting to you. If you have questions, don't hesitate to leave them in the comments.